Hey folks, Todd Coburn here with the Aerospace Structure Series. This video is lecture 1, and this part of that lecture is on significant figures and reporting answers. This video really just applies to my students or students of statics, dynamics, or strength of materials. It applies to a lesser degree to industry professionals. The idea here is we really, even for engineers, we need to manage how many significant digits we show. We don't want to show too few, which compromises accuracy and precision, and we don't want to show more than is reasonable, or at least not much more than is reasonable. Anytime you see a number in industry where the string on of digits that are all meaningless, it kind of undermines the entire analysis as being created by somebody that has no clue what they're doing. In terms of classes, what we're trying to do is have something that is reasonably accurate or sufficient without a lot of extra headache. If you remember back to chemistry, the rules for significant figures are a little bit complicated, kind of a hassle to keep track of. So most basic statics, dynamics, and structural mechanics books that I have seen follow the same plan of where what they'll do is they'll have basically they're reporting 3 significant digits for any number except those that start with 1. If the number starts with a 1, they use 4 significant digits, and for anything else they use 3 significant digits. Of course, that means you got to know what a significant digit is, and some of my students are still struggling with that idea. So if we have 40, 3 significant digits would be 40.0. 15 would be 15.00 since it starts with a 1. And if we practice on a few more, this means 12 would be 12.00. 4.2, that's 2 significant figures, needs a 3rd digit. This is 5 significant digits, so the way we would report this with 4 would be 13.04, and then K, or 1,000 of whatever the units are. This number here, you can see in order to do this, you could say 21.6 times 10 to the 1, 2, 3, 4, 5, 6 to the 6th power, or 2.15 times 10 to the, or 2.16 times 10 to the 7th power, right? This one here, you can see there's 1, 2, 3, 4, 5, 6 significant figures shown. So to follow our rule, we could say 1.563 times 10 to the minus 3, right? Or we could say 1, 2, 3, 4, 5, 6. We could say 1563 micro whatever, like micro inches per inch or something. This 1 point times 10 to the minus 9 is showing only 1 significant digit, and we need to show 4. That is a practical rule. I'm a little bit of a stickler on this in my classes, mainly because engineering is a discipline of a big piece of it is just following directions and careful keeping track of little details and organizing those details. And this ties into all those in addition to taking care of significant figures. So be sure you understand this if you're a student. If you're not, you can ignore this video. Make sure you watch the rest of the videos for lecture 1.